Okay, guys, today, if you are in advanced math trig, honors, mods 2, 3, and 4, you're going to put the date Thursday, April 30th, 2020. So you're going to go 4/30/20, top left of your corner of your paper. If you're in advanced math trig, mod 7. If you are in mod 7, again, you're learning this topic called sums of infinite series, but your date in the top corner of your paper should be what? Wednesday, May 6th, 2020. So again, advanced math trig, mod 7, you're going to put 5/6/20 up in your corner. Okay, again, taking good notes and continuing on with this chapter on sequences and series. The title for today almost sounds like an oxymoron or a contradiction here. Look, it says sums of infinite series. Read that and think about that. How can a series, which remember is a bunch of numbers with plus signs in between them, that's infinite and goes forever, how can an infinite series that goes forever and never stops have a sum? You'd think if I'm going forever, I'm just going to keep adding more and more numbers, and the thing will be sumless because it'll keep getting bigger and bigger. So actually start your notes by posing that question, okay? Put a little arrow down from the title and then pose this question. If a series is infinite and it goes on forever, can it actually have a sum? Okay, question mark. And that's the question of the day. So today we're going to have a series, so it'll be a bunch of pluses or minus signs in between our numbers. It could be arithmetic, it could be geometric like we've been working with. But instead of saying, what's the sum of the first 8 numbers or the sum of the first 32 numbers, I'm going to ask, what's the sum of the whole thing? Okay? Now, a lot of this just involves common sense. For example, okay, the first example or two that I want you to put on your paper before we make a note about it and use common sense to make that note. What if my first example was 1 plus 4 plus 7 plus 10 plus ... Okay, now look at that thing and think about it. Describe what you're looking at. It's an infinite series, agreed? And I'm what? Adding 3 each time to get the next number, agreed? So you would look at this and say that is an arithmetic series whose common difference is what? 3, right? Because I'm adding 3 each time and the numbers are getting bigger and bigger. It's in ascending order. Okay, if I said to you, okay guys, grab a calculator and add all the numbers in that series and tell me what you get. Well, obviously, guys, look, 1 plus 4 is 5, plus 7 is 12, plus 10 is 22, plus 13 would be 35, plus, if I keep adding bigger and bigger numbers to that series, and I go forever, I'm never going to arrive at a sum, am I? Because each time I add a number, the answer just keeps getting larger. So that thing would be, quote, sumless. You couldn't do it. Now, what if it was an arithmetic series that was in descending order? Like this one, 8 plus 5 plus 2. Now, if I am adding negative 3 each time, right? Because the numbers are getting smaller and smaller. So my common difference is negative. Go ahead and write that as your next example. 8 plus 5 plus 2 minus 1 minus 4 minus 7 minus... Now, the numbers are getting technically smaller and smaller because they're getting more and more negative. But think about it. By the way, that is arithmetic, right? But the difference would be what? Negative 3 this time because the numbers are getting smaller and smaller, so I'm adding a negative number each time. Of course, if I kept adding numbers over and over and over again, 8 and 5 is 13, plus 2 is 15, minus 1 is 14, minus 4 is 10, minus 7 is 3, minus 10 is negative 7, minus, and then if I kept going, it's going to get bigger and bigger and bigger in the negative direction. So the point is, an arithmetic series where the numbers are getting bigger and the difference is positive, or an arithmetic series where the numbers are getting smaller because the difference is negative, it doesn't matter. Wouldn't you agree this statement of common sense makes perfect sense? And you're going to put it on your paper, put a big star, and note this common sense statement. It has nothing to do with a formula. Every infinite arithmetic series, whether it's going ascending or descending, is sumless, exclamation point. Agreed? Every infinite arithmetic series is sumless. So we've just concluded that an infinite series that's arithmetic will never have a sum because the numbers just keep getting bigger and bigger, and you would put sumless for the answer. Okay? However, let's keep examining this question. What if my example said, okay, this is the next one on your paper, 1 plus 2 plus 4 plus 8 plus ... Now, careful. Look at that, and if you were describing that to someone, what would you call it? It's an infinite series. Now, aren't I just 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is, this is a geometric series whose ratio is 2. Agreed? And notice when that ratio is a number bigger than 1, the numbers keep getting bigger and bigger. So if I said to you, what's the sum of that whole series, we'd be in the same boat, wouldn't we? 1 plus 2 is 3, plus 4 is 7, plus 8 is 15, plus 16 would be 31, plus the number's just going to keep getting bigger and bigger every time, and I can't arrive at a sum. So we would put for this note, what? A geometric series where the ratio is bigger than 1 is also going to be what? Sumless. Agreed. That's our next note. If it's a geometric series, I look and I notice it's geometric, and the numbers are getting bigger and bigger because the ratio is bigger than 1, that's going to be a sumless infinite series. Again, I'm not asking for the sum of the first 8 or the sum of the first 30 numbers. I want to know the sum of the whole thing. That will be sumless. But finally, you're thinking, what's the point of all this? Look at this next example. Guys, go ahead and write, excuse me, is our next example. 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus ... If I gave you that series that, yes, goes forever, and said, what's the sum of the whole thing? Add all those numbers together. Well, if you got going on that, what's 1 plus 1/2? 1 1/2 plus 1/4 would be what? 1 3/4 plus 1/8. Well, now I'd be at 1 6/8 plus, that'd be 1 7/8 plus 1/16. Oh, wouldn't that be 1 14/16 plus 1? That'd be 1 15/16 plus 1/32. Oh my God, the answer would be 1 31/32. Hey guys, we would get really, really, really close to what? The number 2, but we would never ever get there, would we? It would be impossible to ever get to the number 2. And the rule in calculus is all answers are rounded to the nearest 3 significant place values. So the point is this, guys, if I kept on going and adding numbers, eventually it'd be 1 over, let's say 2 million, plus 1 over 4 million, plus 1 over 8 million. How big is 1/8 millionth? It is so tiny and insignificant that it's basically like you're adding 0 every time. So if I go plus 0, plus 0, plus 0, my sum's not going to change. Now, you're going to say, yes, it is changing. Yes, it's changing way down at like the 17th decimal place. And the 17th decimal place is irrelevant because all answers are rounded to the nearest 3 places anyway. So eventually, when I get an answer to the nearest 3 places for this and keep on adding numbers forever and never stop, it'll never change those 3 decimal places, ever. They'll stay the same and won't change. So technically, this thing has a sum. So I want you to put a note and say, obviously that last note talked about a geometric series and the ratio was bigger than 1. Do you agree this is a geometric series? Oh, but each time I'm what? Timesing by a half, timesing by a half, timesing by a half. So if I keep multiplying by a number that's smaller than 1, these numbers keep getting smaller and smaller. Okay? So if it's a geometric series where the ratio is less than 1, it has a sum! Exclamation point. Wow! If I look and I see an infinite geometric series and the ratio is less than 1 because the numbers are getting smaller and smaller, then it has a sum. Now guys, even if that first number would have been 1,000,000 instead of 1, think about it. 1,000,000 plus 500,000 plus 250,000 plus 125,000 plus what? 62,500 plus 32,200. Eventually, if they keep getting cut in half, you will eventually get to the exact same scenario that this system was doing. It's just going to take longer to get down to the meaningless little numbers that you keep adding. Okay? So any geometric series, no matter what the first number is, if you look and the ratio is less than 1, then that series, even though it goes forever, actually has a sum. And to find that sum, we've got another formula to write down in a box here. Put capital S equals. Now notice that does not say S sub n like that last assignment you did. I'm not finding the sum of the first 8 numbers or the sum of the first 13 numbers, am I? I'm finding the sum of the whole thing. To find the sum of the entire series, even though it goes forever, you take A1 over 1 minus R. That's the shortest, smallest formula we've had to work with. Okay? So think about, remember this one here? We said, man, it's getting really close to 1. Let's go use this formula on that problem we just had on our paper here. If I said, what's the sum of the whole thing? A1, my first number is what? 1 over, now on bottom we've got 1 minus whatever the ratio is, and we said the ratio was 1/2, didn't we? Well, obviously, if you take 1 minus 1/2, you get 1/2. And if I have 1 divided by 1/2, that's 1. Change division to multiplication. Take the bottom fraction and flip it over. Oh, and what's 1 times 2? The sum would be 2. Whoops, there you go. Now you can see it. Remember when we said 1 plus 1.5 is 1.5, plus 1/4 would be 1 3/4, plus 1/8 would give us 1 7/8, plus 1/16 would give us 1 15/16. Oh my gosh, that's getting really, really close where it's going to rub right up against 2, but we'll never go past 2. So we'll never put 2.1 eventually. That will not happen. So the sum of that series is 2. So in theory, it makes sense. So all we're doing problem-wise today, so what if I have this series right here? 0.3 plus 0.03 plus 0.003 plus 0.0003 plus ... Oh, okay, it obviously goes forever. So your first thought is, careful, what's the sum of the whole thing? Don't jump to that formula until what? Until you are convinced that it's geometric and the ratio is less than 1, right? If this was some kind of arithmetic series, you'd say sumless. If it was geometric and the numbers were getting bigger, you'd say sumless. But look, the numbers are getting smaller. What do you do to this first number to turn it into that one? Isn't the ratio going to be, oh God, what is that? Aren't you multiplying by, I don't know, what, 0.1? Does that make sense? Let me see on my calculator. 0.3 times 0.1, enter, is 0.03. 0.03 times 0.1 is 0.003. So this is an infinite geometric series whose ratio is 0.1. Oops, there you go. Ratio is 0.1. Obviously, 0.1 is less than 1, isn't it? So I can actually find the sum of this series and add all these numbers together, even though they go forever. And the sum would actually be, okay, here we go. Let's use our formula. A1 is 0.3 over 1 minus r would be 1 minus 0.1. So that's really 0.3 over, what is that, 0.9? If I want to use my calculator, 0.3 divided by 0.9, I hit enter. Oh my gosh, I get 0.3333. It's a repeating decimal that never ends. And since all answers are rounded to the nearest 3 places when you jump to either statistics or calculus next year, that's the sum of the whole thing. Would that answer ever change? No, because all that's happening is you're adding a 3 to the end of that answer forever. And it's never going to change those 3 numbers, so that's my sum no matter how many numbers I add together. Interesting. Okay, so one more and we're all set here. The last one. What if I have 7 plus 7 halves plus 7 fourths plus 7 eighths plus 7 sixteenths? Now, if you kept going, do you see the pattern? If I said, what's the name of the next number? You'd say, what? Aren't we just multiplying by a half here? Aren't we just doubling the bottom number? So the next number would be 7 32s and then 7 64s and then 7 128s. Ooh, eventually I'm going to have 7 over a billion. 7 over a billion is such a tiny, small number that it's insignificant, right? So eventually, it's like I'm adding 0 every time. You agree? I look at this series. Now, careful. If it was arithmetic, I'd say sumless, right? When you do your homework. If it was geometric and I had a multiplying by the same number every time and it was bigger than 1, I would say sumless. But because it's geometric, the numbers are getting smaller. The ratio is what? 1/2. And by the way, don't put 0.5. If you've got a series that's got fractions in it, your answer has to be in fraction form. Okay, you're not going to add all them fractions together and get a decimal, right? Even if you use decimals on your calculator, convert it to a fraction when you're done. So the sum of this whole series would be, all right, S equals, what's A, my first number, 7, over 1 minus, and then what is the ratio? Aren't you multiplying by 1/2 each time? Oh my gosh, so I got 7 over 1/2, right? Which we know is 7 times, flip it over, 2. Who would have thunk? You add all these fractions together forever, you're going to get an answer of 14. Guaranteed you'd never have it turn into 14 point something else. It'll never get there. The sum of that infinite series is 14. Interesting. Okay? All right. With that in mind, I think that makes perfect sense. Homework would be these 6 problems. If you need to hit pause on your video right now so you can freeze these on your screen and get them copied, you're certainly, job-wise here, is just to write down each of these infinite series. Now, you're not using your formula on all of them, right? Your job is to look, like number 1, I'll help you out here, 3 plus 5 plus 7 plus 9. All I'm doing is what? Adding 2 each time. That's an arithmetic series. So what are you going to do for the answer? Sumless. I want the sum of the entire infinite series. So if it's arithmetic, you're going to put sumless. If it's geometric and the numbers are getting bigger, sumless. The only ones where you're going to use your famous A over 1 minus R formula is if it's geometric and the ratio is less than 1, okay? So 6 problems, big deal. Your job is not to find the next 3 numbers. Your job is not to find the 13th number. Your job is not to find the sum of the first 18 numbers. Your job is to find the sum of the whole series and tell me what it would equal. Try those 6. That's due tomorrow. So if you were in mods 2, 3, or 4, that's due Friday at noon. If you're in mod 7, since today for you it's May 6th, that'll be due tomorrow, Thursday, May 7th by noon. Keep up with the work. We're getting there, guys. We're into May. We got one more section of this chapter yet to go, and then we're down to our last little unit together, okay? All right, great job. We'll see you tomorrow.